Hello, Professor. Today I'll be presenting how we can use Python to work with detailed cricket data, specifically IPL ball by ball records, and build a software pipeline that helps us predict match outcomes. It's all about extracting the right features from messy sports data. Uh, like Coming to the second slide, like what is the problem? So sports, like in sports like cricket, data is collected for every single ball. Like that's great, but it also means the data is huge and not model ready. If we want to predict like which team might win, like we need to turn this data into something meaningful, and that's where aggregation pipelines help. So like what is an aggregation pipeline? Uh, Think of the pipeline like a factory, like raw data goes in and we clean it, group it by teams of players, calculate useful stats, and finally we get features that our prediction model can use, like a player's average or or a team's economy rate. And, and why is this a software task? So this is not just statistics, it's software. Like we write code to do all of this step by step in Python. We use pandas to group data, filter events, and merge different roles together like batting and bowling stats. It's a reusable, programmable system. And like what kind of data are we using? The two main files I use are like deliveries.csv, which has every ball from every match, and matches.csv, which summarizes each game. Like together, they give a full view of what happened and when. And what are the stats do we build? Once the data is clean, like we compute compute useful stats for players, like we track how well they batted or bowled. For teams, like we calculate win percentage and power play performance. We even include fielding like catches, and this gives us a rich data set. And coming to the second seventh slide, like this advanced feature engineering, like to make it realistic, like we only use past data before each match, just like in real life. And we also use rolling averages, like how a player did in the last 5 matches, and we split performance by power play or death overs. These are like advanced meaningful features. And what happens after, we will models like XGBoost or random forest, like which you use it to predict winners. And once all features are ready, like we build match level table. We have fed this into machine learning models like random forest, XGBoost, to predict who's more likely to win. The better our features, the smarter the predictions. And how this approach works, the secret is not just the model, it's the data that goes in. By building this pipeline, like we are turning complex raw sports data into something models can learn from. And this approach works for any sport with detailed event logs. And coming to the real world applications of this, this has real applications like from fantasy sports and betting tools to match commentary and team decision making, and and coaching strategies and team evaluation also. And anyone using data in sports can benefit from a system like this. And coming to the final thoughts about this, to wrap up, like this project shows that prediction starts way before the model. It starts with data cleaning, feature building, and understanding the game. So software like this pipeline help makes better, smarter predictions using real sports data. That's Thanks for listening.